अस्सलाम वालेकुम सर।
अस्सलाम वालेकुम।
सर अभी सर
ठीक है साकिब, ये इस वीक ना फ्राइडे को होगा, ठीक है। 2 टॉपिक्स में दे देता हूँ, वो प्रिपेयर करने हैं।
ओके
क्लास के एंड में, क्लास एंड होती है तो कर लेते हैं।
सर,
अच्छा,
क्योंकि सर मैंने न्यूज़ रीड की थी, ओ लेवल्स ए लेवल का सर एग्जाम टाइम पे होंगे आर्टिकल।
हाँ जी, वो तो आ गया, अब तो हो रही एग्जाम, ठीक है। देयर इज नो कंफ्यूजन इन दैट, ठीक है। अच्छा चलो, लेट्स स्टार्ट विद दिस पेपर, न्यू पेपर, ठीक है। दिस वन इज क्वेश्चन पेपर 4-3 winter 16 and and you have the first question, ठीक है। The first question is about copper being a transition element and it has atomic number 29, ठीक है। तो ये दिया हुआ है, complete the electronic configuration of the atom of a copper atom. Remember, copper is a special case. So 29 electrons would be 3D. वैसे it's going to be argon के पास there is 3D and 4s. 4s gets filled first and then you have 9 electrons over here. But copper is a special case in which the completely filled configuration is more stable. So that is why it's going to have 3D10 or 4s, but there's only going to be 1 electron. Okay? Remember, copper and chromium. Of a +2 electrons are always lost from the outermost shell. Okay? So an electron would be lost from the 4s. So the 4s would be 0. And 1 electron would be lost from the 3D. So there would be 9 electrons over here. तो ये +2 उसकी oxidation state है. Here he's saying name the type of reaction that's occurring here. Maria, what do you call this reaction?
Sir, Ligand exchange.
ठीक है, that is ligand exchange. Just one second. अच्छा, so this one is it is ligand exchange and state the colors of the complexes. Remember, copper with water, that is blue in color. What is copper with Cl when Cl is attached? What is the color?
Green.
ठीक है, that's going to be green. Or the reality is that it is yellow. ठीक है, just let me simultaneously open a marking scheme, especially for this one. ठीक है, sometimes they give this as yellow. In reality, it is yellow, but it kind of looks green because उसके अंदर वो blue mix हुआ होता है. So which is why it's kind of greenish yellow. ठीक है, just let me check what's the exact color that they're using, or are they using both? So we'll open over, then we'll check. State the shape with Cl ligands. What's the shape of the complex?
सर टेट्राहेड्रल।
ठीक है, that's tetrahedral. ठीक है, remember Cl is a bigger ligand, so it's going to be tetrahedral. ये खुला क्यों खुला? अच्छा नहीं, sorry. So we'll check the color later. Write the expression for the stability constant for this equilibrium. It's this one over here. So it's going to be products over reactants. So it's going to be CuCl4 2 minus its concentration. These are your products. Water, its concentration, and we're going to come to water just in a moment. Divided by the reactants, and the reactants are these are your reactants, Cl and tetra aqua copper complex. So it's CuH2O6 2 plus. Remember, the charge is written within the bracket. The brackets represent concentration. and then there is Cl minus 1, and its concentration is to the power 4. Now, now remember this, when you have water as, and when you have an aqueous, I mean, I'm assuming this is aqueous, copper 2 complex. Did they mention aqueous anywhere? Usually in aqueous state, water concentration is so high that it is not written. Uh, they haven't really mentioned aqueous anywhere, so I'm assuming it is aqueous. But let me just confirm this. But remember this: for water, water is not written in the expression if the solution is aqueous, because there are so many water molecules that its concentration is very high, and it is practically not changing or constant, becomes constant. Okay, I'm just going to check water. अच्छा ठीक है, either over here yellow and green both are accepted. Okay, so that's fine. And over here exactly water is not written in the expression. Okay, for K stability, water is not given. Although they hadn't explicitly said that it was aqueous anyway, uh, because it was CuH2O6 2 plus, so we're assuming that it was an aqueous solution. As the next one is this: what is meant by the term bidentate ligand? What's a bidentate ligand?
It forms two dative bonds
Okay, so it's a ligand
with
that's
the
capable
central
of,
neutral atom.
exactly, ligand that forms two dative bonds with a metal cation. Next one is you're given stability constants for the two complexes. What do these K stability values tell us about the relative position of Equilibria 1 and Equilibria 2 relative? So the second one for Cu, En, H2O4, that's higher. So what does higher mean? Stability constant is basically an equilibrium constant. Equilibrium constants are products concentration divided by reactant concentrations. So if if products are higher, they're more products, then obviously K stability is going to have a higher value. In relative terms, the first one is lower. So I'm going to go back, and he's talking about the two complexes which are given over here. The second one is higher. That means there's more chances of this forming. And the first one relatively is lower. That means that products are going to be formed in a lesser quantity. So there's going to be lesser products. So you have to mention the position of the equilibrium, that this is, I think he was talking about the position of TK. He was talking about the relative position of Equilibria 1 and Equilibria 2. So what you're going to state is that for the second one, the equilibrium is favoring the products. It's more to the right. And for the first one, the equilibrium is favoring the reactants, or relatively less products would be formed in the first one. Okay, is this clear? Sarah, is this clear?
Yes.
Achha, next is part D. Nickel forms the complex ion in which it is surrounded octahedrally by 6 nitrogen atoms. Name the type of stereoisomerism displayed by nickel En3. And this is one type of, and you have to draw the two stereoisomers. Now, this is the one that you have to remember. What information he's told us that it is octahedral and it's surrounded by 6 nitrogen. Although this is something that you have to remember because it's given in the syllabus as well. So you have to exactly remember this particular type of isomerism. Now, octahedral would be that it's going to be surrounded by 6 nitrogen atoms. The question is stating that already. Okay, so and there's going to be one bond on top and one bond at the bottom. That's the first thing. What is En? Okay, the 3 ENs. En was a bidentate ligand that they mentioned somewhere over here. Where is Where is Ian? Okay, they actually never
It's in part C.
in part C. As a exactly. This is
Yes, yes, yes,
ठीक है.
yes.
Yes, this one. So it's basically this molecule over here. This is known as Ian, where Ian TK it's explicitly stated that. So this is Ian. Two CH2s, and on two sides there is an NH2. So you're going to add this En over here, and when we do that, so there is NH2 lone pairs, and they're two connected to two CH2s. Okay, that's one. Then another bidentate En would be attached over here. There's going to be NH2, and it would have CH2s attached to it. And then there's going to be another one which is NH2. और फिर यहाँ पे there's a CH2, another CH2, and the lone pair is getting attached. That's a first type of isomerism. Uh, a molecule like this forms optical isomers. That is, it has two non-superimposable mirror images. So what you're going to do is you're going to make a mirrored version of the same molecule. And I'm just going to quickly do this without going into a lot of detail. You can fill in the details later. Same thing, nickel, except I'm just going to roughly sketch this. Draw the mirrored version of this molecule. So I'm just going to represent En with two things. I mean, this thing over here is attached over here. So in the mirrored version, the molecule would be attached on this side. You can add in the details later. This is attached over here. So in the mirrored version, the molecule En would be attached over here. And the last one, the mirrored version would be En getting attached over here. Okay, so remember, optical isomerism. In optical isomerism, this is the only example that you have to remember. And optical isomerism that you have studied is the one with bidentate ligands. These two are connected, these two are connected, and these two are connected with a bidentate ligand. Okay, so you have to remember exactly this particular example by heart. I said next is ethane 1,2-diamine is a useful reagent in organic chemistry. Explain how the amino group allows the molecule to act as a Bronsted-Lowry base. So why is it capable of acting as a base?
Sir, the nitrogen has lone pairs, which can accept a proton.
Okay, so you have to explain. You didn't have to actually write an equation. So you're going to talk about the lone pairs, and you're going to write about them accepting that they accept H+1 ions, which is why they act as base. And you can write an equation for this. Actually, you should write an equation for this because it's a 2-mark question. You can show an H getting added to this. The second mark is probably for that. Compare. No need to write the equation. They just gave you 2 marks for that. I said next is write an equation for the reaction of this with an excess of hydrochloric acid. So I said now you're going to write an equation. So what you're going to write is that HCl reacts with it, and you can have CH2, and there would be N lone pair would accept NH+1. So there's going to be NH2, and a Cl-1 would be attached as well. or you can ignore the Cl-1 simply. So now, under certain conditions, it reacts with ethane dioic acid to form the polymer Z. Draw the structure of the polymer Z showing 2 repeat units. So this is how polyamides are formed. Polyamides are formed when a molecule has NH2 on both sides, which means it's a diamine. And the other molecule has a carboxylic acid group on both sides. So the H and the OH are going to get they're going to get removed. The OH would be removed, the H would be removed, so you can rub them off. So this H and OH is gone, a water molecule is going to be produced. And they're going to link up. So this is your amide. This is your amide link that is produced. And name the type of reaction. So it's an example of condensation. Polymerization. You can remember polyesters, polyamides, and complex carbohydrates. They are examples of condensation polymers. Okay, Sakib, is this clear?
Yes, sir.
Achha, polymer Z is an example of biodegradable polymer. Name a polymer that is non-biodegradable. Achha, remember all these condensation polymers, the ones that contain amide links, the ones that contain ester links. These are very polar links, and all of them are biodegradable because they can be hydrolyzed by water. Because they're so polar that they attract water molecules and they tend to react with water molecules. Remember this, all condensation polymers, N has lone pairs. It's a very strong partial negative, H is very strongly partial positive. O has lone pairs over here, so it's partial negative, carbon is partial positive. So they all tend to attract molecules, and these linkages are very, very reactive. So what are polyamides? Your proteins are polyamides, your nylon is polyamide, Kevlar is polyamide. They are all, and polyester. What is polyester? Polyester is terylene that's used in clothes and fabric. Fats are an example of polyesters. So these linkages are very reactive, and they tend to biodegrade or break down. I mean, this chain would break down because it would react with water because it's highly polar. Okay, this is highly negative. This is highly positive. So polyesters, polyamides, condensation polymers generally are biodegradable. Does anyone know which polymer is non-biodegradable? Mariam, any idea?
Any additional polymers, so like a polyethene?
Okay, so they are the ones that are not biodegradable. Just one second. So they're the ones that are not biodegradable because they are basically carbon chains, and carbon chains are relatively strong. Okay, so for example, if you have an alkene, so that alkene, and I'm drawing a polyethene molecule. So what happens with a polyethene molecule is that all the chains are carbon-carbon chains. They all link up. The double bond in the middle kind of turns into a single bond. So carbon chains are highly nonpolar. They're not very reactive. And carbon-carbon bonds are very strong. Carbon is a very small atom. It only has 6 protons. Smaller atoms, they make strong bonds. So they're very stable bonds. So they're kind of very stable bonds. You can remember small atoms, they make strong bonds. Plus, they're non-polar as well. So they're not going to be attracting other molecules. which is why they're not going to break down easily. Okay, so name a polymer, you can just name polyethylene or PVC or any addition polymer. As the next one is when copper 2 carbonate is heated, strongly decomposes in a similar way to group 2 carbonates. Predict what would be observed when anhydrous copper 2 carbonate is heated. Now he's talking about observation. क्या बनेगा पहले तो ये बताओ. What would be formed? Anyone?
Sir,
Sarah?
copper oxide and oxygen.
ठीक है, but he's not. He's talking about observation. So what's the observation? What's the color of copper carbonate?
Um, is the observation like white precipitate or
No, but
colorless?
first thing,
gas?
what's the? What's the?
Oh
what's,
yes, the
Sir, you
carbon
will
dioxide.
observe a gas effervescence.
नहीं, it's not effervescence नहीं observe करोगे because it's not happening in water. ठीक है, it's anhydrous without water, so मतलब you won't see bubbles.
Sir,
forming.
white solid, white solid.
The
Because
copper is a transition metal. It's not going to form white solids. Remember, this is green in color. ठीक है, and copper oxide is black. ठीक है, किसी ने कहा था. So that's that. किधर गया? अच्छा, that is black precipitate, black solid. ठीक है. ये याद रखना colors. ठीक है, दोनों. You have to remember this. अच्छा, describe and explain how the thermal stability of group 2 carbonates varies down the group. Now he's talking about group 2 now. So first thing is they become more stable. Down the group, एक mark तो इसका
thermal
मिल गया.
stability. Sir, can you explain same for the nitrogen compounds?
Same, दोनों का same ही है ना.
Sir, but nitrogen का तो descent होता है ना, means उसकी thermal उसकी temperature required to decompose decreases for nitrogen.
Higher होता है. Down the group more stable होता है. उसका भी stable होता है. Nitrates की बात हो रही है, nitrogen की नहीं.
So nitrates, sir.
और इसकी रीजन क्या होती है? रीजन ये होती है कि ऊपर वाले जो cations होते हैं, they're smaller in size. ठीक है, so if you have a 2+, right, and you have a carbonate ion, नीचे जब down the group जाओगे तो again you're going to have a 2+, but the cation is going to be bigger in size. ठीक है, it's going to be bigger in size. So what would happen is down the group, why do they become more stable? कि इसका 2+ charge इतना concentrated and it has a very high charge density कि it pulls the oxygen away, it polarizes the carbonate ion, and उसके electrons जो यहाँ पे bond हो रहे थे उसको खींच के वो अपने साथ जोड़ लेगा. ठीक है, and it would form MgO, for example, and this CO2 molecule would break off. ठीक है, so it pulls the oxygen or attracts the oxygen so strongly that the whole molecule breaks up, carbonate ion breaks up. Over here, that's not the case. The 2+ charge is on a bigger atom, the charge density is lesser. And if the charge density is lesser, so it won't attract the oxygen that much. So it won't form, अगर ये barium है ना, it won't form barium oxide. ठीक है, it's not going to pull the oxygen away from it. So that's why stability increases. So the things that you're going to write over here are that क्या क्या लिखोगे? The first
So
thing
this
is
means the temperature required to decompose increases down the group, right?
हाँ, तो एक तो ये लिखोगे down the group. ये शॉर्ट ही कर लेते हैं, वो खुद ही डिटेल में आंसर लिखते हैं ना. तो cationic radius increases. So what happens down the group? Charge density decreases. And if it decreases, there's less polarization of the carbonate ion. CO3 -2 ion. बस यहीं तक ले दो काफी है. Less polarization, hence they become more stable. Next is you have, what is this? You have a CN2 molecule. You saying complete the dot and cross diagram for the CN2 -2 ion. So C we know that it has 4 electrons, sorry, in its outer shell. So I'm just assuming it's going to share 2 electrons over here, 2 on the other side. Nitrogen is also going to form a double bond. Achha, now nitrogen has a total of 5 electrons. Carbon ka outer shell complete ho gaya. Carbon cannot accommodate more than 8 electrons. Carbon is the second shell. ठीक है, remember second shell cannot have more than 8 electrons. अगर third period का होता ना, third shell का, so it could accommodate more than 8 electrons. But right now carbon cannot accommodate more than 8 electrons. So 8 electrons in total. That's done. Carbon is done. Nitrogen has a total of 5. So 2 इधर share किए, so they're left with you're left with how much? 3 electrons. And this one also 3 electrons. Now nitrogen's outer shell is not complete because it's 4 over here, 5, 6, and 7. So इसका मतलब है there's going to be 2 electrons. अच्छा, इसका you have to follow this, but we can ignore this for now. And because it has a charge of -2, so to complete the outer shell, nitrogen gained 2 electrons from outside. Or kahan se outside? It gained it from calcium. There must be a calcium atom that would be losing 2 electrons. Only then would CaCN2 would be formed. So the 2 electrons would complete the outer shell of nitrogen over here. ठीक है, अब बोला clear है? अच्छा, CaCN2 decomposes readily on contact with water. So CaCN2 contact with water. So what is it forming? It's forming an insoluble white solid. What's the insoluble white solid? And ammonia only. So what's the insoluble white solid? वो क्या चीज है?
Sir, sulfate or
Sulfates? नहीं.
or oxide होंगे sir. Oxides are basically white. Calcium oxide.
ठीक है, कैल्शियम हाइड्रोक्साइड होगा क्योंकि ऑक्साइड जो होता है वो वाटर के साथ रिएक्ट कर जाता है. ठीक है, तो इट्स प्रॉब्ली गोइंग टू बी कैल्शियम हाइड्रोक्साइड्स, वो पार्शियली इनसॉल्युबल होता है. ठीक है, सो फॉर्म्स अ सॉलिड वाइट प्रेसिपिटेट. Just hold on 1 second. एक सेकंड वेट
सर
करो.
कैल्शियम हाइड्रोक्साइड सॉल्युबल नहीं है वाटर में because magnesium hydroxide is insoluble और हाइड्रोक्साइड की solubility increases करती है down the group.
अच्छा, क्या कह रहे थे? के
सर कैल्शियम हाइड्रोक्साइड soluble नहीं होगा, slightly soluble because
पार्शियली
down the
सॉल्युबल.
group
डाउन द ग्रुप
hydroxide
इंक्रीज होती है ना. MgOH2 is insoluble. CaOH2 is partially soluble.
yes sir.
तो मतलब ये बीच में ये भी काफी इनसॉल्युबल होता है. ठीक है, स्ट्रॉन नीचे जाते हुए फिर और ज्यादा इंक्रीज होती है सॉल्युबिलिटी. स्ट्रोंशियम हाइड्रोक्साइड इज सॉल्युबल. बेरियम हाइड्रोक्साइड इज इवन मोर सॉल्युबल. क्लियर है?
yes sir.
तो इधर कोई और ऑप्शन नहीं है ना. सल्फेट्स तो हो नहीं सकते. सल्फर कहाँ से आया? कैल्शियम और वाटर में कैल्शियम हाइड्रोक्साइड इज द ओनली पॉसिबिलिटी. ठीक है, और तो कुछ भी नहीं बन सकता. ठीक है. अच्छा, next one is about question number 3, spontaneity of the reaction. तो पहले तो वो कह रहे हैं कि let's jump right to the question. वो कह रहे हैं magnesium reacting with hydrochloric acid. So let's write down the equation. It's Mg plus HCl plus HCl and it forms MgCl2. अब बताओ कि disorder को क्या हो रहा है? Is it increasing or decreasing?
Sir, increasing.
Increasing.
And why is it increasing? Explanation क्या होगी?
H2 gas.
ठीक है, there's a gas forming. ठीक है, so it increases, H2 gas is formed. या a simple gas formed. ठीक है, a solid and a liquid, they turn into a gas. Potassium chloride dissolving, so KCl solid. When it dissolves, it forms aqueous ions. So K plus 1 aqueous, Cl minus 1 aqueous. So why is the disorder increasing? But it is increasing. Yeah. Y का क्या आंसर होगा?
More ions.
ठीक है, so KCl
Sir, disorder decrease नहीं होगा because there is an attraction between ions.
नहीं, वो डिसोसिएट हो गया ना. KCl was an ionic solid, ठीक है, उसको पानी के अंदर मिक्स किया. पहले तो वो सारे एक दूसरे को अट्रैक्ट कर रहे थे ना. ठीक है, लेट्स से एक टाइनी क्रिस्टल है KCl का. जब आप स्पून से हिलाओगे, all the ions would dissociate in water. ठीक है, वो सारे they'll all get scattered in water. ठीक है, so they dissociate into aqueous ions. तो दूर दूर हो गया ना, डिसऑर्डर क्रिएट हो गया ना. क्लियर? साकिब क्लियर है?
Yes, sir.
अच्छा, स्टीम कंडेंसिंग टू वाटर, तो ये तो आसान है. क्या होगा एंट्रोपी चेंज? नेगेटिव. ठीक है, बिकॉज नंबर ऑफ गैस मोल्स डिक्रीज. ठीक है, गैस ही खत्म हो गया. अच्छा, नेक्स्ट वन. you're given कि डेल्टा जी कैलकुलेट करो. ठीक है, तो उसने is asking you to calculate delta G, which is the Gibbs free energy. What's the formula for calculating delta G? Delta G is equal to delta H minus T delta S. ठीक है, that's the formula. Ab, what information is given? The enthalpy change is given. That's already there. So that's 117 minus temperature is given. That's 298 kelvins. It should be in kelvins, 298. And then you have delta S. That is not given. That information is nowhere. Like what's given is you're given the entropies of all the products and the reactants. So delta S का एक formula होता है, which is कि products की entropies and you subtract the reactant entropy from it, and that way you'll get the delta S, the change in entropy. So it's basically the entropy of the products minus the entropy of the reactants. Somebody take out a calculator and tell me what the value is. It's going to be the products are MgO, that's 26.9, plus CO2, that's 214. So these are the entropies of my products, and I'm going to minus 65.7. Mole सारों के 1 है. So can anyone tell me what the delta S is in this case?
Is it 175.2?
100. ठीक है, I'm not sure. वो check कर लेंगे. 175.2, right? And remember, delta S is in joules per mole per Kelvin. So you have to be careful with the unit which is given over here. It's joules per mole per Kelvin. तो यहाँ पे जब use करोगे ना, तो इसको convert कर लेना, because this is in kilojoules. ठीक है, this delta H is in kilojoules. This is in joules. So the unit has to be the same. So it's going to be 117 minus 298 minus 298. Just one second. ठीक है, so it's minus 298 multiplied by 175.2, but the whole thing will be divided by 1000. तो क्या वैल्यू आ रही है डेल्टा जी की?
Is it 64.8?
अच्छा, 60.
64.79.
क्या वैल्यू आ रही है डेल्टा जी की? 64.8. So just one minute for the azan. ठीक है. अच्छा let's start again. ये तो आंसर ठीक था, एक हमने बीच में ना गलती की है, which is this one, क्योंकि कार्बन को तो हम भूल ही गए थे कि यहाँ पे कार्बन भी था, और ये एक्चुअली कार्बन का प्रोडक्ट था, कैल्शियम कार्बोनेट था. ठीक है, we didn't have a look at carbon, वो उसको हमने इग्नोर ही कर दिया था, तो कार्बन था ही नहीं प्रोडक्ट्स के अंदर. So this had to contain carbon. ठीक है, ये सही कर लेना. अच्छा, next is, what's the next question? You have अच्छा, why does this reaction become more feasible at higher temperatures? So I'm just going to discuss. आवाज आ रही है? साकिब आ रही है?
Yes, sir.
अच्छा, so feasibility of the reaction. What is feasibility of the reaction? Gives free energy. Agar overall, if it's coming out to be negative, that means the system has enough energy for useful work and would usko बाहर से energy नहीं चाहिए. That means overall the reaction is exothermic. So why does this become more feasible at higher temperatures? So if you look over here, uska jo delta H hai, that's endothermic. Uska jo delta H hai, that needs energy. ठीक है, that part is endo. ठीक है, plus 117 था. यानी it's consuming heat energy. But लेकिन the work done due to entropy change, what is that coming out to be? इसका जो delta S है ना, that's what is delta S? Delta S is positive. यानी इसका मतलब it's creating disorder. ठीक है, positive means that disorder is created. And whenever disorder is created, that means work is produced. That means it's going to be exothermic. Okay, so whenever disorder, gases are created, things would explode, disorder is created, and that's an exothermic process overall. So delta S is positive. So जब वो T से multiply होगा, it would automatically become negative. That means it's exothermic. And if it's exothermic, higher temperature would make delta G negative. And why would it make delta G negative? Because if you have a bigger T, so ये term that would become bigger. And that's already negative, that's exothermic. So if you have a higher temperature, delta G would become negative. That means the system overall is producing work rather than consuming work. Uska jo delta H wala part hai, that's endothermic. That part is consuming energy. Lekin uski jo entropy change wala part hai, that part is producing work. So overall, if you have a bigger T, to wo zyada disorder create karega. More energy would be produced, given out in the form of useful work, and the delta G would become, overall it would become negative. ठीक है, तो ये आपने लिखना है. Is this clear? Maryam, clear? Sara, is this clear?
Yes,
Yes,
sir.
G sir.
Sir, if the value is higher, this means the reaction is more feasible, or value is low.
Negative. Delta G gives free energy, ना? That's the total energy. क्योंकि system दो तरीकों से work produce करता है, ठीक है? One of them is the enthalpy change, जो वो heat energy produce करता है या consume करता है. The other one is the entropy change. उसकी वजह से जो work done create करता है. मतलब माचिस को आप जलाते हो ना, तो माचिस क्या करता है? हीट प्रोड्यूस करता है ना. ठीक है, तो एक तो वो तरीका है कि आप हीटर को जलाते हो, आग जलती है, ठीक है, इट प्रोड्यूसेस एनर्जी. लेकिन द अदर थिंग इज कि आप किसी चीज को कोई रिएक्शन होता है और एकदम से गैस प्रोड्यूस होती है. मतलब वाटर लिक्विड है, इट ऑल ऑफ अ सडन चेंजेस इनटू गैस, इवन दो इट्स एन एंडोथर्मिक प्रोसेस. लेकिन बिकॉज ऑफ द एंट्रोपी चेंज, अ लॉट ऑफ यूजफुल वर्क वुड बी क्रिएटेड. यानी इफ यू हैव अ पिस्टन, और खुद सोचो कि अगर वाटर जो है वो लिक्विड है और वो एकदम से गैस के अंदर कन्वर्ट हो जाएगा, तो गैस के मॉलिक्यूल्स क्या करेंगे? इस पिस्टन को ऊपर की तरफ मूव करेंगे. ठीक है, तो वर्क प्रोड्यूस होगा और वो पार्ट एक्सो होगा. ठीक है, साकिब, ये बात समझ आइए कि सिस्टम दो
Yes, sir.
तरीके। तो ओवरऑल सिस्टम को ना इन दोनों को कंबाइन करके इट शुड बी एबल टू प्रोड्यूस वर्क। तब वो रिएक्शन ना यानी नेगेटिव आएगा, दैट मींस इट्स गोइंग टू बी एक्सोथर्मिक। दैट मींस उसको बाहर से ना कोई एनर्जी नहीं चाहिए, इट्स एबल टू डू एवरीथिंग ऑन इट्स ओन। ठीक है, वो बल्कि एनर्जी प्रोड्यूस कर रहा है। तो हायर टेम्परेचर पे द रिएक्शन वुड बिकम मोर फीजिबल, क्योंकि ओवरऑल इट वुड प्रोड्यूस मोर वर्क एंड इट्स गोइंग टू बिकम मोर नेगेटिव। तो डेल्टा जी को नेगेटिव बनाना है, जितना वो नेगेटिव होगा ना उतना वो फीजिबल होगा। जितना वो पॉजिटिव होगा ना, अगर टी को जीरो कर दो ना, तो इसका मतलब है कि एंट्रोपी चेंज से तो कुछ फर्क नहीं पड़ने वाला। डेल्टा एच एंडोथर्मिक है, तो उसको तो डेल्टा जी डेल्टा एच के इक्वल हो जाएगा एंड दैट वुड बिकम एंडोथर्मिक एंड दैट वुड मीन कि आपको उसको एनर्जी देनी पड़ेगी, वरना वो रिएक्शन नहीं होने वाला। अच्छा, next one is you have to calculate the minimum temperature at which this reaction becomes spontaneous, feasible. Delta G को क्या होना चाहिए? Negative. Delta G is equal to delta H minus T delta S. So delta G should be negative for it to be spontaneous. That means that delta H minus T delta S must have a value that is smaller than 0. Negative का ही मतलब है ना, it should be negative. So you have to calculate the temperature and you have to solve this inequality. How will you solve this inequality? The delta H is given, that's 130. Units का ख्याल रखना कि the units are not, this is kilojoules and this other one is joules. So minus T, delta S, which is 316, लेकिन it should be converted into, convert that into kilojoules. तो वो less than 0 होगा, ठीक है? Bring this whole thing on the other side, so it's going to become T times 316 divided by 1000. ठीक है, तो ये मैं I've taken this to the other side, and then you have to do is कि T निकालो, T, this should be taken to the other side, so it's going to be 316. So your T would be greater than, it's going to be greater than this thing. क्या temperature आ रहा है?
Is it 41.08?
कितना? 4? Sarah, what's the answer?
We multiplied like this. Is it 41.08?
49.08?
No, 41.
41.08.
Yes.
So just let me check the answer. No, it's coming out to be 410.
Yes, I think I did a mistake.
ठीक है, मतलब the expression is the same. It's just coming out to be 400. I mean, it's maybe you missed out 410 Kelvins. Achha, group 2 sulfates down the group. You have to explain the trend. ये हर पेपर में एक question होगा. क्या होगा इसका answer? Anyone? Can anyone tell me? Mariam, any idea?
Sir, down the group, they increase because the
They decrease.
lattice energy decreases more than hydration energy.
So the first thing is that down the group they decrease, ठीक है? Like barium sulfate is insoluble. MgSO4 is soluble. So down the group they decrease, that's 1 mark, and the reason is पहले तो बताना कि cationic radius increases. You have to break the lattice. You split the ions away from each other. So Mg2 plus and SO4 2 minus, they scatter, they turn into gaseous ions, and immediately they bond with water molecules to form aqueous ions. So that's enthalpy of hydration. This part is exo and this part over here is endo. So the first mark is it decreases down the group. The second mark is that the ions become, the cation becomes bigger. So both lattice energy and enthalpy of hydration, they decrease. Both of them decrease. Bigger ions, they don't form strong bonds. So both of them, they decrease. But since the solubility is decreasing, that means the endo part is relatively bigger compared to the exo part. So lattice energy decreases less compared to enthalpy change of hydration. Okay, so these are the 3 points that you have to always remember. And in hydroxides, it's the opposite. Okay, so remember these. I mean, you have to remember this. Group 2 sulfates, group 2 hydroxides. This question is always in every paper. Asap here, just quickly, what's a transition element? Okay, 1 mark. ये बस करके खत्म करें. Sarah, what's a transition element?
It's when the D element forms unstable ions.
It forms stable ions with incomplete D subshells.
Yes, with incomplete subshells, D subshells.
D subshells. So it's an element that forms stable ions with incomplete D subshells.
Yes.
So ठीक है, we'll continue with the same paper next class tomorrow. ठीक है? Same time. Okay, then take care. Allah Hafiz.
Allah Hafiz.
Hafiz.